Most of what exists in the cosmos is invisible to us. This is not about distant galaxies or elusive stars, but something much more mysterious. Dark matter, the invisible glue that holds galaxies and the entire universe together, yet remains beyond the reach of our direct observations. A pervasive component of the cosmos that shapes the structure of the universe in ways we are only beginning to understand. Everything we see in the universe, from galaxies through stars to planets, constitutes merely 5% of the total mass and energy of the actual universe. The remaining 95%, as scientists claim, consists of 27% dark matter and 68% dark energy. While the sight of the Andromeda galaxy, with its stunning swirling dance of billions of stars, takes your breath away, it also becomes the arena of one of the greatest cosmic mysteries that has tantalized and eluded scientists' solutions for decades. This refers to the invisible web that keeps this entire astronomical machine in motion, dark matter. Imagine for a moment our galaxy, the Milky Way, home to the solar system where planets dance around the sun, each at its own, precisely calculated pace. They dance faster the closer they are to their source of life, with Mercury spinning at a frenetic pace, while lazy Jupiter rotates decidedly slower. This is the order dictated by Kepler's laws, unyielding and predictable. But what if we tell you that galaxies, these gigantic clusters of stars, do not operate according to these principles? When scientists peered through their telescopes, expecting to see the stars on the outskirts of the Andromeda galaxy moving slowly, like the lazy Jupiters of space, they instead discovered something that defied all expectations. These stars were speeding at velocities that should have flung them into the depths of space, yet they remained in their orbits, as if some invisible hand was holding them on a leash. This is precisely where the dark matter controversy arises. This invisible, inexplicable substance that seems to be the very glue holding galaxies together. In 1933, against the backdrop of the infinite darkness of space, Austrian astronomer Fritz Zwicky noticed something that turned the existing understanding of the universe upside down. While observing the Coma galaxy cluster, he discovered something surprising. Galaxies were moving at speeds that seemed impossible to achieve, if only visible matter was considered. Instead of being flung into cosmic void, they behaved as if they were part of a larger, invisible whole. Zwicky faced a paradox. How is it possible that galaxies do not flee from each other, even though they should? His answer was as revolutionary as it was disturbing. There must exist some elusive form of matter, invisible to our telescopes, but exerting a tremendous gravitational influence. He called it dark matter. The breakthrough came in the 1970s, when further research showed that stars on the outskirts of galaxies orbit at speeds that could not exist without the presence of significant amounts of invisible matter. This was the moment when dark matter ceased to be just a theoretical concept and became a central element in the quest to answer what really holds galaxies together. A key moment was the discovery of gravitational lensing, a phenomenon where light from distant objects is bent by an invisible mass, creating strange but fascinating patterns in the sky. These cosmic mirages gave scientists a new tool to map the unseen and offered evidence for the existence of dark matter that could not be ignored. A theory comes to the forefront, the existence of massive weakly interacting particles known as WIMPs. According to scientists, these may be the key to solving the dark matter mystery. Simply put, these are particles that have a lot of mass, are heavy, but interact very weakly with normal matter and light, making them invisible. Scientists believe that these invisible WIMPs could form huge, invisible clouds around galaxies, acting like a kind of cosmic skeleton that helps hold galaxies together. Without this cosmic glue, galaxies would fly apart due to their rotation. But how can we find something that is invisible? Here, a very clever method comes to the rescue. Scientists use detectors made of a metal called germanium, which is cooled to extremely low temperatures, close to absolute zero, the lowest possible temperature in nature. When an invisible WIMP particle hits a germanium atom, it causes a tiny increase in temperature, which the detectors are able to register. These special detectors are placed deep underground, for example, in abandoned mines, to avoid interference from cosmic radiation and other particles that could affect the experiment. It's a bit like looking for a quiet whisper in a noisy room. We want to hear only the quietest sounds, eliminating all other noises. But what if there are other explanations? Among them are two particularly interesting alternative theories. The first is the theory of modified Newtonian dynamics, invented by an Israeli physicist in 1983. According to it, gravity, the force that makes an apple fall to the ground, works a bit differently than we thought, especially over very large distances, like between stars in galaxies. This theory suggests that gravity does not weaken as quickly as we move away, which could explain why galaxies do not fall apart while rotating. The problem is that this theory does not explain well the behavior of larger structures, like clusters of galaxies, which is why it is not widely accepted. The second theory is the so-called electric universe theory, which posits that the universe is filled with rarefied plasma, a state of matter similar to gas, but with charged particles. The movement of this plasma would create electromagnetic fields that influence the shape and motion of galaxies, without the need to include dark matter in the equation. This idea has its proponents, but most scientists consider it unlikely. Despite these alternative theories, the majority of scientists are still searching for dark matter, using the latest tools and technology, such as the Large Hadron Collider, a gigantic machine that could help detect these mysterious particles. Let's go back to basics. The universe is a vast place that is constantly changing. Albert Einstein once thought that the universe was like a large static painting. It does not change, does not grow, does not shrink. But for this to make sense with his equations, he had to add something to them, which he called the cosmological constant, a kind of cosmic force that would hold the universe together, preventing it from collapsing. Then another scientist, Edwin Hubble, discovered that the universe is not static at all. It is growing, expanding. This was like telling Einstein that his cosmic glue was not needed. Einstein thought that this was his biggest mistake. But the story doesn't end there. In recent years, we have begun to understand that the universe is not just growing, but it is doing so at an accelerating pace. It's a bit like if, after stepping on the gas in a moving car, instead of moving at a constant speed, the car suddenly starts to accelerate. This is where dark energy comes into play. It is this gas for the universe. Dark energy, instead of attracting things towards itself like gravity, think of an apple falling to the ground, repels them from each other. It works as if the universe has a built-in mechanism that causes it to expand faster and faster. How do we know this is true? A certain experiment called the Casimir experiment showed that even when it seems like there is nothing in space, something is still happening there. Small particles appear and disappear, suggesting that empty space is full of energy. This energy could be responsible for pushing the universe apart. I must admit that theories about dark matter and dark energy do not convince me. True, There are calculations and observations suggesting that something invisible, dark matter and dark energy, shapes the cosmos in ways we cannot yet fully comprehend. Nevertheless, it would not be surprising if, in the future, perhaps decades from now, the universe again surprised us by revealing new layers of its mystery, which explain its behavior in ways we can't even dream of today. After all, the universe is far more extraordinary and mysterious than we can imagine. Our journey through cosmic mysteries doesn't have to end here. We invite you to subscribe to our channel, where you'll find more videos delving into the universe's secrets, from the latest theories to incredible discoveries. Don't miss the chance to explore with us what's hidden beyond the visible universe. Subscribe and join our community of knowledge seekers to not miss out on the next fascinating findings.